You are watching channel Number Collage. Through this channel, we take sincere efforts to make you understand and like mathematics in a simple and easy manner. In this video, we will understand about the basics of trigonometry. Trigonometry literally means measure of a triangle in terms of trigonometric ratios. Now, what is a trigonometric ratio? Trigonometric ratio is the ratio of lengths of sides of a right triangle related to a particular angle. In right triangle ABC, AB and BC are the right angle making sides, whereas the side opposite to this right angle is hypotenuse AC. We can have trigonometric ratio of angle A, of angle B, or of angle C in terms of the ratios of lengths of side AB, side BC, and side AC. The sides are named in relation to the angle of which we write a trigonometric ratio. In right triangle ABC, if we want to write trigonometric ratios of angle A, then side opposite to angle A becomes BC and side adjacent to angle A is AB. If we want to write trigonometric ratios of angle C, then side opposite to angle C is AB and side adjacent to angle C is BC. So we observe that as the angle in a right triangle changes, the meaning of the adjacent side and opposite side also changes. Sine, cos and tan are the three basic trigonometric ratios, so we will write basic trigonometric ratios of angle A. In right triangle ABC, sine A is side opposite to angle A divided by hypotenuse, that is BC divided by AC. Cos A is side adjacent to angle A divided by hypotenuse, which is AB divided by AC. AB divided by AC. Tan A is side opposite to angle A divided by side adjacent to angle A, which is BC divided by AB. BC divided by AB. Cosec, sec and cot are the reciprocals of these basic ratios sine, cos and tan. We will write reciprocals of these basic ratios for angle A. In right triangle ABC, we write cosec A equals hypotenuse divided by side opposite to angle A, that is AC divided by BC. AC divided by BC. Sec A equals hypotenuse divided by side adjacent to angle A, that is AC divided by AB. AC divided by AB. And cot A equals side adjacent to angle A divided by side opposite to angle A, that is AB divided by BC. AB divided by BC. Now we will write basic ratios sine, cos and tan for angle C. In right triangle ABC, now we will write trigonometric ratios of angle C, and we will see how the opposite side and adjacent sides change in relation to angle C. So side opposite to angle C is AB and side adjacent to angle C is BC. So we write sin C equals side opposite to angle C divided by hypotenuse, that is AB divided by AC. AB divided by AC. Cos C equals side adjacent to angle C divided by hypotenuse, that is BC divided by AC. BC divided by AC. Tan C equals side opposite to angle C divided by side adjacent to angle C, that is AB divided by BC. AB divided by BC. Now we will see reciprocals of basic ratios, that is cosec, sec and cot of angle C. In right triangle ABC, please note that the opposite side and adjacent side in the relation to angle C. We write cosec C equals hypotenuse divided by side opposite to angle C, which is AC divided by AB. AC divided by AB. Sec C equals hypotenuse divided by side adjacent to angle C, which is AC divided by BC. AC divided by BC. Cot C equals side adjacent to angle C divided by side opposite to angle C, which is BC divided by AB. BC divided by AB. We will understand the relationship between basic ratios and their reciprocal ratios of angle A. We have right triangle ABC, in which opposite side and adjacent sides have been written in relation to angle A. Sine A multiplied by cosec A equals BC divided by AC, which is sine A multiplied by AC divided by BC, which is cosec A. AC divided by BC. BC gets cancelled, AC gets cancelled, so we get 1. Therefore, sine A multiplied by cosec A is 1. Cos A multiplied by sec A equals AB divided by AC, which is cos A, multiplied by AC divided by AB, which is sec A. Now AB gets cancelled, AC gets cancelled, and we get 1. So cosec A multiplied by sec A is 1. Tan A multiplied by cot A equals BC divided by AB, which is tan A, multiplied by AB divided by BC. AB gets cancelled, BC gets cancelled, and we get 1. So tan A multiplied by cot A equals 1. Now we will rewrite this relationship in a different form. We write sine A equals 1 divided by cosec A. 1 divided by cosec A. We divide this one by sec A and write cos A equals 1 divided by sec A, and we divide this one by cot A and write tan A equals 1 divided by cot A. So we have sine A equals 1 divided by cosec A, cos A equals 1 divided by sec A, and tan A equals 1 divided by cot A. Let us understand relationship between sine, cos, tan and cot ratios of angle A. We have right triangle ABC, where side opposite to angle A is BC and side adjacent to angle A is AB. We write sine A divided by cos A equals BC divided by AC, which is sine A, AB divided by AC, which is cos A. AC gets cancelled, so we get BC divided by AB, but this is tan A. So we get a relationship tan A equals sine A divided by cos A. Now we write cos A divided by sine A, which is AB divided by AC. which is cos A, and divided by BC divided by AC, which is sin A. AC gets cancelled, so we get AB divided by BC, but this is cot A. So we get relationship cot A equals cos A divided by sin A. Let us understand how to write higher powers of trigonometric ratios. Sin theta whole to the power n is written as sin to the power n theta. Cos theta whole to the power 2 is written as cos square theta. Tan theta whole to the power 3 is written as tan cube theta. Cosec theta to the power 4 is written as cosec to the power 4 theta. Sec theta whole to the power 5 is written as sec to the power 5 theta. Cot theta whole to the power 6 is written as cot to the power 6 theta. We will solve problems based on trigonometric ratios. If tan A equals 4 divided by 3, find the other trigonometric ratio. Let us draw a right triangle ABC. Tan A equals 4 divided by 3, and tan A is opposite side divided by hypotenuse, opposite side divided by adjacent side. So we write in triangle ABC, BC equals 4K and AB equals 3K, where K is a common multiple. By Pythagoras we will find AC. We write AC squared equals AB squared plus BC squared. Substitute the values: 3K for AB, 4K for BC, 3K whole squared will be 9K squared, 4K whole squared will be 16K squared, 9 plus 16 will be 25K squared. So AC will be under root 25K squared, which will be 5K. So we will write AC equals 5K here. Now we have all the three sides of this right triangle, so we are able to write the remaining 5 trigonometric ratios. We write sin A equals BC divided by AC, which is 4K divided by 5K, which will be 4 divided by 5. So sin A is 4 divided by 5. Cosec A is reciprocal of sin A. So we write cosec A equals 1 divided by sin A, that is 1 divided by 4 divided by 5, which will be 5 divided by 4. Cos A will be AB divided by AC, that is 3K divided by 5K, which will be 3 divided by 5. So cos A is 3 divided by 5. Sec A is reciprocal of cos A. So we write sec A equals 1 divided by cos A, which is 1 divided by 3 divided by 5, which will be 5 divided by 3. So sec A will be 5 divided by 3. Cot A and tan A are reciprocals of each other. So we write cot A equals 1 divided by tan A. Tan A is 4 divided by 3. So it will be 3 divided by 4. So cot A is 3 divided by 4. If sec theta equals 13 divided by 12, find the other trigonometric ratios. We have right triangle ABC, whose angle A is theta degrees, where theta is a Greek letter used to denote angle. Sec theta equals 13 divided by 12. Sec theta is defined as AC divided by AB, and since it is a ratio, we will write AC equals 13K and AB equals 12K. Now we will find one of the right angle making sides, that is BC. So in triangle ABC, AC is 13K, AB is 12K, where K is common multiple. By Pythagoras, BC squared equals AC squared minus AB squared. AC is 13K, AB is 12K. 13K whole squared is 169K squared. 12K whole squared is 144K squared. 169 minus 144 is 25K squared. So BC is under root 25K squared, which is 5K. So we write BC equals 5K here. Now we know all the three sides of this right triangle. So we will write the remaining trigonometric ratios. We write sine theta equals BC divided by AC, which is 5K divided by 13K, which will be 5 divided by 13. So sine theta will be 5 divided by 13. Cosec theta and sine theta are reciprocals of each other. So we write cosec theta equals 1 divided by sine theta. Sine theta is 5 divided by 13. So it will be 13 divided by 5. So cosec theta is 13 divided by 5. Cos theta and sec theta are reciprocals of each other. So we write cos theta equals 1 divided by sec theta. Sec theta is 13 divided by 12, which equals 12 divided by 13. So cos theta is 12 divided by 13. Tan theta is BC divided by AB, which is 5K divided by 12K, which will be 5 divided by 12. So tan theta is 5 divided by 12. Cot theta and tan theta are reciprocals of each other. So we write cot theta equals 1 divided by tan theta. Tan theta is 5 divided by 12. So it will be 12 divided by 5. So cot theta is 12 divided by 5. If cot theta is 7 divided by 8, evaluate 1 plus sine theta multiplied by 1 minus sine theta divided by 1 plus cos theta multiplied by 1 minus cos theta. Here, from the value of cot theta, we will find the values of sine theta and cos theta, substitute in here and evaluate. We have right triangle ABC, where angle C is theta degrees. Cot theta is a ratio and it is defined as BC divided by AB. So we will put BC equals 7K and AB equals 8K. Now we have to find AC squared. So by Pythagoras we will write AC squared equals AB squared plus BC squared. We will substitute the values 8K for AB, 7K for BC. 8K squared will be 64K squared. 7K squared will be 49K squared. 64 plus 49 will be 113K squared. So AC will be under root 113K. So we will write AC equals 113K. We have all the three sides of this right triangle, so we can write sine theta equals 8K divided by 113K, which will be 8 divided by 113. So sin theta will be 8 divided by under root 113. Cos theta will be 7k divided by under root 113k. So it will be 7 divided by under root 113. So we have cos theta equals 7 divided by under root 113. Now we will write the statement of which we have to find the value. In this statement we will substitute the values of sin theta and cos theta. So we write sin theta as 8 divided by under root 113 and cos theta equals 7 divided by under root 113. 1 multiplied by under root 113 will be under root 113 plus 8 divided by under root 113. So similar calculation can be done with this and with this. So we get this expression. Here under root 113 is in numerator as well as in the denominator. So this gets cancelled and we get under root 113 plus 8 multiplied by under root 113 minus 8 divided by under root 113 plus 7 multiplied by under root 113 minus 7. Now the product of these two terms and these two terms will be 113 minus 64, because this is of the form a plus b multiplied by a minus b. So this product will be a squared minus b squared. Under root 113 squared will be 113 and 8 squared will be 64. Here also the same thing happens. Under root 113 squared will be 113 minus 7 squared will be 49. Now 113 minus 64 is 49. 113 minus 49 is 64. So the value of this expression is 49 divided by 64. 3 cot A equals 4. Check whether 1 minus tan square A divided by 1 plus tan square A equals cos square A minus sin square A. We write 3 cot A equals 4 as cot A equals 4 divided by 3. From this value of cot A, we will find the values of tan square A, cos square A and sin square A and show that or check whether the left hand side is equals the right hand side. We have a right triangle ABC, and since cot A is a ratio 4 divided by 3, we write AB equals 4k and BC equals 3k. Now by Pythagoras, we write AB squared plus BC squared equals AC squared, or AC squared equals AB squared plus BC squared. We will put the values. We have AB equals 4k, BC equals 3k. So 4k whole square will be 16k squared, 3k whole squared will be 9k squared, 16 plus 9 will be 25k squared. So AC will be under root 25k squared, that will be 5k. So we will write AC equals 5k here. Now we have all the three sides of this right triangle. So now we will find out tan square A, cos square A and sin square A. First, sin square A will be BC square divided by AC squared. That is 3k squared divided by 5k squared. K squared gets cancelled with this k squared. 3 squared is 9, 5 squared is 25. So sin square A equals 9 divided by 25. Now cos squared A will be AB squared divided by AC squared. That is 4k whole squared divided by 5k whole squared. K squared cancels with this k squared. 4 square is 16, 5 squared is 25. Tan square A will be BC squared divided by AB squared. That is 3k squared divided by 4k squared. K squared cancels with this k squared. 3 squared is 9, 4 squared is 16. So tan square A is 9 divided by 16. Now we will substitute these values in this expression and verify whether the left hand side equals right hand side. Now the left hand side is 1 minus tan square divided by 1 plus tan square. We have tan square A equals 9 divided by 16. So 1 multiplied by 16, that is 16 minus 9 divided by 16. 16 plus 9 divided by 16. 16 gets cancelled and we get 16 minus 9, that is 7. 16 plus 9, that is 25. So LHS is 7 divided by 25. Now we will solve the RHS, which is cos squared A minus sin squared A. We will substitute the values. Cos squared A is 16 divided by 25 minus sin squared A is 9 divided by 25. Since the denominator is same, we will subtract the numerator directly. So 16 minus 9 is 7 divided by 25. So RHS is also equal to 7 divided by 25. Since LHS equals RHS, we can say that 1 minus tan square A divided by 1 plus tan square A equals cos square A minus sin square A. In triangle PQR, right angled at Q, PR plus QR equals 25 cm and PQ equals 5 cm. Determine the values of sin P, cos P and tan P. We have a right triangle PQR, right angled at Q. PQ is 5 cm, which is given. We have to find PR and QR. We are given PR plus QR equals 25. So we will write QR equals 25 minus PR. Now we will use Pythagoras and write PR square equals PQ square plus QR square. Now since PQ is given, we will express PQ in terms of PR and QR. PQ square equals PR squared minus QR squared. Now PQ is 5 cm, so it will be 5 squared. PR squared minus QR squared is difference of two squared quantities. So this can be factorized as PR plus QR multiplied by PR minus QR, out of which PR plus QR is given to be 25. So we will put 25 for this and write 25 equals 25 multiplied by PR minus QR. So PR minus QR becomes 25 divided by 25, which will be 1. Now we have QR equals 25 minus PR. So we will substitute here minus 25 minus PR equals 1. That is PR minus 25 minus becomes plus PR equals 1. Now PR plus PR is 2PR equals 1 plus 25. This minus 25 goes to the right hand side, becomes plus here. So it will be 26. So PR becomes 26 divided by 2, which is 13. Now we write PR equals 13 here. Now we will substitute the value of PR here and write QR equals 25 minus 13. which will be 12. So we write QR equals 12 here. Now we have all the three sides of this right triangle. So now we can find sin P, cos P and tan P. So sin P will be QR divided by PR, 12 divided by 13. So sin P will be 12 divided by 13. Cos P equals PQ divided by PR, 5 divided by 13. So cos P will be 5 divided by 13. Tan P equals QR divided by PR, 12 divided by 5. So tan P will be 12 divided by 5. This is about basics of trigonometry and trigonometric ratios. Hope you liked this video. If you did, please press the like button and share this video with the students of class 10 and their parents. Subscribe this channel to get more simple videos on mathematics. Thanks for watching. Have a nice day.